Okay, so yesterday we looked at evaluating limits just by um, looking at the graph, right? What?
Looks like it's very similar to what we did with logs.
Really it's kind of not. Uh, okay, so yesterday we looked at graphs. Today we're going to look analytically. Okay, so we don't have to look at the graph every time, basically. Okay, so here are some rules that are in your book. So you can write them down or you can reference them in your book. But basically, if we have two separate, like if we know that the limit as x approaches c of f is L, and the limit as x approaches c of g is k. All right, so these are our rules. If we know the limit and we multiply a number in front of the function, we can multiply that number to the limit.
Then H or B?
B. You can, it could be any number as long as the number is the same, right? If we add or subtract functions together, we can add or subtract their limits together. If we multiply functions together, we can multiply their limits. If we divide our functions, we can divide their limits. And if we take our function to a power, we can take our limit to that power. Okay, so these are just, you know, if we already know the limit exists at c and we do something with that function, with these rules, we can do something with the limit as well. So we wouldn't have to like you know, if we know the limit as x approaches c of f and the limit as x approaches c of g, we wouldn't have to add f of x and g of x together to find the limit. We can just add their limits together. It's just kind of a shortcut for you. Okay, so let's talk about finding limits. So you'll have some problems where it'll say the limit as x approaches 5 of f of x is 2, and then it's going to ask you to do some work with that limit. Yes?
Let's say K prime, are we trying to make the word with K?
No, this is a comma because k can't be 0.
Oh.
Okay, so because we can't divide by 0. As long as that limit isn't 0, then we're okay. All right. So you're gonna have some problems where, let's see. Like, I'll do a little example. If we know that the limit as x approaches 1 of f is 2, then if I ask for the limit as x approaches 1 of 2 times f of x, that limit would be I have some more examples later on down the road, so we can look at those in a little bit. Okay, so these are just the basic rules. We can do these with the limit. So now we're going to actually look at how do we evaluate limits. We need this first in case we have functions that are added together. okay? And I'll show you what that looks like. So the very first thing that you need to try when you are given a limit to evaluate analytically means not the graph, okay? Direct substitution is always the first thing we need to try, okay? So here are like the three basic direct substitution limits. So if we have the limit as x approaches c of a constant, it's going to be a constant, y. Okay? If our function is a constant, we have a horizontal line. Okay? It doesn't matter which x value I pick to approach, we're going to have the same limit for all of those x values. Okay? If we have the limit as x approaches c of x, okay, all we have to do is plug that number into x to get c. Okay, we're actually, because we're thinking about what coordinate are we approaching, and so we can actually plug that x value into our function to figure out the y value that we're approaching. Okay, so that's kind of what it's saying here and here. Okay, we can plug in our x value to see what y value we're approaching. We can plug in our x value to see what y value we're approaching. So let's look at this limit right here. We have the limit as x approaches 2 of 5. Okay? 5 is our function. What's the limit as x approaches 2? 5. We don't have to draw the graph. If you have a constant as your function, that is going to be your limit every time. Don't draw the graph every time. The limit as x approaches 2 of x. 2. Okay? If we want to think about the graph, we know that this is what y equals x looks like. Here at 2, we're approaching the y value of 2, okay, because the coordinate is 2, 2. But we're not going to draw the graph every time because we know what's going on. What about the limit as x approaches 2 of x cubed? 8. Because we know graphically, without having to actually make the graph every time, that we have the coordinate to 8 that we would be approaching. Now we're going to kind of mix those two slides together. Okay? Now we're going to take kind of some combinations of functions, whether we're like adding x to the powers together, like a polynomial, right? Or dividing polynomials, what have you. Our method is still going to be the same. So we call this direct substitution. If we have a polynomial or a rational function with a non-zero denominator. I'm going to have that real quick. Okay, polynomial, we all know what those are, right? X to a power plus x to a power plus x to a power, where all of those powers are positive integers, or actually whole numbers, okay? And rational functions with non-zero denominators. We can't divide by 0, so this is not going to apply unless that fraction has a non-zero denominator. So as long as we have a polynomial or a rational function where when we plug in our number it's not 0 in the denominator, we can simply just substitute in, okay? So you don't have to write all of this right here. This is important right here. The limit as x approaches c of our function is just the value when you plug c into your function. Okay? Because we know that there's a coordinate there that our graph would be approaching. Same thing if it's a rational function, as long as your denominator is not 0, then you're going to just plug in c to your function.
Hey. Got paper for Zach.
Email.
Oh, John.
Got the receivers test?
Oh, yeah. Just events. Got a nice little class here.
I'm missing 4 people.
Hey, you're missing Brady and Nate.
Brady and Nate.
And Aaron.
Skipping.
Or tennis.
Tennis is more important than math today.
I wouldn't skip. I would make sure I was here for this class.
Oh, shit. Get out.
By the way, they're going to watch this video and hear everything you say.
You're recording right now?
Yes.
Wait, you're recording? No, wait, there's only two.
Yeah. Woo! I record you guys. Okay. So what does this look like? I have a polynomial. Not done? Not done? Not done.
That's gonna be on the video and.
How do you record from there?
Magic.
Like how can you like?
Where's my
There's a microphone in this. On my computer.
I'm gonna talk after you. You're gonna shut the video off.
No, I keep.
Okay. Are we ready?
The next.
Here we go. So, first of all, the limit is x approaches 3 of 3x plus x squared. Okay? We have a polynomial. All we have to do is do what with that 3? Plug it in. Direct substitution. So our limit is, because on our polynomial we have the coordinate 3, 18. As we approach the x value of 3, we are approaching the y value of 18. Okay. All right, direct substitution here. Oh, let's try that again. 2/27. Since 3 does not make our denominator 0, then we're good. We can just plug it right in. Okay. The same thing applies to roots functions. What do I mean by root? Square root, cubed root, whatever, anything with a radical, okay? As long as we have just the radical, we can use the direct substitution as long as the x value is in our domain, okay? We have domain restrictions on even radical functions, correct? Yes, right? Square root of x, we can't plug in negative numbers, okay? So, hopefully you don't get a limit as x approaches -2 of the radical x, okay? We can't evaluate where we don't have domain. Correct. But we're still going to do the same thing. We're going to just substitute in. So the limit as x approaches 3 of the square root of 3x squared, we're just going to throw 3 in there. And how do we write that? We do not do the plus or minus unless we're solving, like x equals. Okay. Will I let you leave it as a square root of 27?
Yes.
I will. You're an AP calculus. You don't have to simplify anymore. However, you could also give it to me as 3 radical 3. The AP test does not require you to simplify, so I will not either.
Oh, that makes me happy.
It's kind of a nice relief, right? Like, okay, I can focus on,
Yeah, one less thing you're
But it's
going
probably like 2 columns on the exam that involves that.
okay. So what happens if we have a rational function where we're plugging in for direct substitution and it causes us to have a denominator of 0, okay? What are we going to do? Now, but sometimes, okay? Let's think about rational functions. If we have a rational function where our denominator is 0, there are 2 different things that could be happening. What's one of them? A whole. The other one would be?
Or unbounded behavior.
Okay. We'll call it an asymptote for right now, but then yes, when we look at the limit, it would be unbounded behavior or a break. Okay, so if our denominator is 0, we either have an asymptote there at that x value or a whole at that x value. Okay, if there's an asymptote, we're not going to have a limit because we're going to have unbounded behavior. However, if there's a whole, could we have a limit? Yes. So, who can tell me when do we get a whole in a rational function?
And you cancel out.
When we can cancel out factors, okay? So if we try to plug this 2 in, what happens? We have a 0 in the denominator. Well, before we say that the limit doesn't exist, let's go ahead and factor everything out. And what happens? We have factors that cancel. And so now we're left with the limit as x approaches 2 of x plus 2, which would be what? 4. So the limit does exist because it's a whole there. All right? So graphically, we have this x plus 2 where at 2, 4, we have a whole. And so the limit exists because we're approaching that value of 4. Okay? But we had to do some algebra to get there. Okay? So do not give up right away if your denominator is going to be 0. Factor and see if anything can cancel, and then try direct substitution. There's another way that we would have to do some algebra magic. Yes?
Wait, can I I was just about to say, it's basically 2 from the right and then 2 from the left. After you can put in 2.1 for x, where seeing it slightly from the right, and then 1.9 from the left, check to make sure the behavior terms are the same.
Okay, and then are you talking about when we get to the asymptotes? I think that's what you're.
More like for break.
Okay, and we'll talk about that in a couple days. Okay. Let's talk about this. Okay. When we plug in 0, what happens?
0.
Okay, so we want to say does not exist. However, we may be able to rearrange this fraction to where when we plug in 0, it wouldn't cause us to divide by 0. So I see a radical there, right? We can't just square everything because we're not working with a equation. What else can we do?
You can multiply both the top side and the bottom side of the function by by radical x plus 1 plus 1.
Yes. And what is that called?
The, oh.
Starts with a C. O. N.
Commutative.
Nope. Yes, the conjugate. Very good, Charlie. That is called the conjugate. Okay? So now, if we multiply by the conjugate, you have A minus B times A plus B. And when we multiply A minus B and A plus B, we get A minus B times A plus B is A squared minus B squared. So this becomes the square root of x plus 1 squared minus 1 squared all over this. Okay. So what happens in our numerator? We get x over x times blah, 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 blah. And then what can happen? We can cancel out the x's. And so now we have the limit as x approaches 0 of 1 over radical x plus 1 plus 1, which would be over 2. Square root of 1 plus 1 would be 2. Yeah. Yeah. Whew.
That wasn't.
Oh, okay. I was like, what? I was like, it's like I was so confused. Yeah.
There's a lot of places to go
It's
wrong.
honestly not bad.
Yeah.
Or not that hard.
Don't make the other mistake.
Wait, there's more.
There is more, but
Oh.
okay. Guys, is that really strenuous algebra there that we did?
I mean, in the book, it'll be probably 10 times harder.
It's not.
Probably.
It's going to look very similar. Okay, your numbers are going to be different, but it's going to look similar. Okay, so if you plug in for direct substitution at 0, multiply by the conjugate, you'll be okay. All right. Let's talk about the composition. Okay, so like f of g of x, right? Sorry, that's if we have the limit as x approaches c of g of x is L, so our limit is L, and the limit as x approaches c of f is K, so the limit is K. Then when we talk about the composition, okay? Okay, it's just a composition, right? We're plugging G into F. So the limit that you get for, okay, let's maybe go one step. Let's maybe rewrite this differently. You don't have to rewrite it differently, okay? Let me rewrite it differently. So the limit as x approaches L of f of x. This would mean the same thing, right, with direct substitution. So if we evaluate the limit of g to be L, now we're going to evaluate the limit of f as x approaches that limit that we just found. So we find the limit of the inside function and then use that number to help us with the limit of the outside function. Right? I mean, it's just composition. Okay.
The G of X equal L. And then you plug that into the next part. Yeah.
Yeah. Okay, so let's do an example. So the limit as x approaches 2 of f composed with g. So what do we get when we plug 2 in for g? Square root of 2. So we're talking about the limit as x approaches square root of 2 of our function f. Okay, so we plug 2 into g to get radical 2. So now we're looking at the limit as x approaches radical 2 of our outside function, which we would do radical 2 squared plus 4.
It looks so much harder on the last slide.
I know, and that's why we do examples, okay?
Like looking letters and
Because it's all, yeah, it's all letters, okay? And it's unfamiliar notation, right? Okay, how do you do this one?
Plug 2 in for each equation for like
Plug 2 in for each equation, right? When you plug 2 in for f, we get? And when we plug 2 in for g? And guess what? You can leave it like that. Whew. Okay? Last thing that we need to talk about is the difference quotient. This is very, very, very important. This is the difference quotient. Write it down. Does it look familiar?
yes.
Yes. Okay, instead of delta x, you might have used an h on your summer homework and on your quiz the other day. Okay. Delta x means what? Change of x. Okay. So we are going to evaluate the limit of the difference quotient. You have had practice with the difference quotient. Now we're going to take the limit of it. So we're going to do this one. Okay, nice and simple. So we have the limit as delta x approaches 0 of f of x plus delta x squared. So we're going to take 2 of x plus delta x squared. Right? That's f of x plus delta x. Okay? Minus f of x all over delta x. If it helps you, if you want to change all of these to h's instead of delta x's, that is fine. Okay? It means the same thing. Okay? What should we do in the numerator? What? What should we do first?
squaring.
Okay, the squaring part, and then distribute the 2, right?
Okay.
So we have x squared plus 2x delta x plus delta x squared minus 2x squared all over delta x, right?
You serious?
So this is just 2 times the first times the second. All right, so can we simplify all in one step here? We know we're going to distribute this through, right? So this is 2x squared minus 2x squared that goes away. And then we have 2 times 2x delta x. And then we have 2 times delta x squared. We can.
Greetings, Titans and Titanettes. It's time to get up out of your seats for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. You can sit down. Time for your student bulletin. Sportsmanship reminder. Springfield gives the Council a great reputation as a school that supports their teams in a positive manner. Let's make this a great fall sport season for our school and community. Have fun and cheer on the Tigers. Seniors. Any senior who did not make their senior graduation announcement, please see Mrs. Lindsay in E12 today. National Honor Society. The meeting for
Okay, factored up, canceled.
to pick up National
What do
Honor
we do
Society
with 0?
will be Friday, August 28th.
Plug it in.
At
For
3:30
delta
p.m.
x.
in room E14. Pep Rally Committee. Any seniors interested in being part of the Pep Rally Committee this year will need to meet in Mrs. Ronder's room, D05, on Friday, August 28th, during third lunch. Please let Mrs. Rogers or Mrs. Brown know if you have any questions.
If you need to change delta x to h, I do not have a problem with
If you're
that.
interested in running for student
If you want to
council,
change
see
delta
Ms.
x to
Cloud
h, I
in
don't have a
B01
problem
or
with that.
Ms. Kelly in B18 for an application. They are due by Friday, August 28th. Today. Flag football, Campview South intramural flag football teams are forming now. Get a sign-up sheet in the PP office from Coach Lina. You will need 5 players to play. Deadline for joining the league is Friday, August 28th. Question, see Coach Lina in the PE office. Attention, all business, marketing, and former DECA members. The first DECA chapter meeting will be Monday, August 31st, in the gym at 7 p.m. The theme is Fiesta. Come see what DECA is all about and join us for nachos, games, and fun. See Miss Gillen in room B14.
You keep it and don't lose it.
Hope to see you there. Circle of Friends. Circle of Friends is a group that helps promote awareness and acceptance of students with autism and other disabilities. We are currently looking for students who would like to assist their peers in gaining social skills and social acceptance in a fun and safe environment. An informational meeting will be held on Tuesday, September 1st at 7:20 a.m. in room C09. Math Club. Math Club will be meeting every first Wednesday of the month. Please join us in Mrs. Holman's room.
Sorry, I forget that it does that. There you go.
That's it for today, Titans. Please come to the football game tonight and have a great day and a great weekend.
This happened.
Yes.
How long do